The Everledger Battery Passport has been developed with the critical guidance and input of key industry organizations. The result is a solution that directly addresses the three pillars for a sustainable battery value chain, including the provenance of critical battery minerals, greenhouse gas accounting, and battery lifecycle management. We can begin with the supplier profile for a critical minerals miner. Miners are given a digital fingerprint at the mine that identifies its location for tracking throughout the supply chain. OEMs and other stakeholders in the value chain can access the Everledger platform for information on a particular mine, the minerals being extracted there, and view mine certifications and compliance claims. Users can also access evidence of greenhouse gas accounting. Here we demonstrate how we are able to ingest and display utilities data to gain an understanding of carbon accounting for any given supplier. This takes into account energy consumption from non-renewable sources, such as coal, using a standard equivalency to connect the energy and GHG values in terms of CO2e, or carbon dioxide equivalent. Moreover, this dashboard can display an estimate of GHG per asset, which will enable efforts toward Scope 3 reporting. Here we see total emissions, total offsets, and per asset GHG, in this case for 1 ton of nickel. And finally, in this example, we can see GHG produced over time and the offsets applied. All sources of energy indicates the total energy used, and the sources of that energy as well as more exact data points. GHG emissions by source is a graph that displays CO2e values, which are derived from non-renewable energy usage multiplied by a coefficient dependent on the exact energy source. Total GHG emissions by location is simply a partitioned view of the GHG values by location, and in this case, only one location is represented. Renewable versus non-renewable power usage is a month-to-month view of all the energy data. This can be especially valuable as a view for users to monitor continuous improvement toward net zero emissions. Now we move into battery lifecycle management and can showcase experiences for three key users: the OEM, the primary recycler, and the secondary recycler. OEM users, which may include employees in sustainability, risk management, regulatory affairs, or customer service, can log into a custom dashboard. In this case, they are tracking both batteries and modules. Of course, cells and other battery components can be tracked as well. This particular dashboard shows batteries and modules that have been removed from vehicles, those that have been disassembled or recycled, and a small percentage that have not yet become active on the platform. Dashboards can be customized according to the needs of a specific auto OEM, and underlying data is dependent on activities that occur downstream. Similarly, this particular view shows batteries and modules that are no longer in use in a vehicle, those that have been disassembled or recycled, and also a small percentage that have not yet become active on the system. To view individual assets, users can navigate to the vault. Here they will see a collection of their batteries as digital assets, or battery passports. Each battery passport is associated with one physical, serialized battery. Modules are also digitized in the same way and are associated with the parent battery to provide another layer of traceability. Clicking into any battery passport will uncover information about its journey. The About page displays attributes provided to the platform by the OEM's own dataset. Chemistry data is also provided. State of health is the only dynamic data set displayed on this page. As the state of health decreases over time, those insights are immutably recorded on the platform and seen from this view. The Journey page displays the lifecycle information on a battery as it changes hands and users attest to the processes occurring downstream. Here you can see this battery has reached the end of its life and been disassembled. This effectively ends the journey of the battery pack, but users can click through to uncover the extended journey that individual modules have experienced. They can also click through to see information on other modules that were previously associated with the pack. Users can also go back to review the parent battery. The next user is the primary recycler, who are often responsible for the disassembly of a pack, recycling metals and plastics locally, and shipping modules or cells to secondary recyclers that recover cathode material. Primary recyclers have a custom dashboard view as well, where they can access a tool to scan the tag on the battery in order to view its data. Once the battery passport is open, the recycler can see it in their vault and discover further information. From here, they can disassemble the pack, which in this case contains 8 modules. Now the recycler's vault has those 8 modules in place of the pack. They can now select individual modules to create a shipment to a secondary recycler. This provides the secondary recycler with valuable data on incoming shipments that was never available before. The secondary recycler now has received the shipment of the modules and will use the platform to access detailed information and also use the platform to share recycling proof and key recovery data with the OEM. Again, an initial dashboard view leads users to the scanning application, which places that module in their vault. From there, they get detailed information on the chemistry, the weight of minerals in that particular module, and then are able to move to recycle it. With data on battery minerals content entering the recycling system, even with batch processing, the recycler can estimate the weight of battery minerals produced in the output. In the near future, regulatory compliance.